I know which one's two.
The questions were 6 or 11? 10? Did I make up one? Alright, so our first one was potassium nitride. Arrow. Okay? So you can, is it recording?
Yeah.
Okay. You can tell that this is a decomposition because it has a compound arrow, right? If it's a decomposition, you have to determine, is it one of the three types or is it not? Okay? Is it a carbonate, chloride, or hydroxide?
No.
No. Okay? Is it an acid?
No.
No. So you're just going to break it apart monoatomic. Y'all don't need to be on your phones or your computers. No need.
I'm trying to submit the thing. Is it the combustion and single replacement? Or
No.
something?
Synthesis and decomp. So we're just going to break it into its two pieces. Alright, so we have predicted the product, now we need to build it. So potassium nitride is a compound. Compounds have charges, charges tell you subscripts. So potassium is a K with a +1 because it's on Greek 1. Nitride is nitrogen with a charge of -3. Now 1 and 3 don't match, so I need to lasso those charges down. So 1 comes here, 3 comes there. Now I have 3 times 1 is 3, 1 times 3 is -3, so we are good. Yield, potassium plus is just potassium, so it's just K. Nitrogen, what's nitrogen?
Diatomic.
And 2, yes, diatomic. Okay, so what, we have built it, now we balance it. So I'm gonna start with K, end with N. So I have 3 Ks, 1 K, 1 nitrogen, 2 nitrogens. So I need to make my K's balance on either side. So the only one I can change is this one. So I'm gonna put a 3 in front to make 3. Okay, now my nitrogen's out of balance, so the only one I can affect is this one. How do I get this nitrogen to a 2? Put a 2 in front. You cannot change this number because that is already in the building process. We finished those. So that would give me 2 nitrogens, but it also changes my K, right? It affects everything in the compound. So 2 times 3 gives me 6K. How do I get 6K on the product side? I just changed the 3 to a 6. I can change that 3 because that's something that I put there during the balancing process. So I can change it. All right, any questions? I ordered new erasers with magnets.
I have a something that you won't use them.
Bill, I got 3 of them.
Miss Cole also got a bunch and she doesn't use them.
Well, I don't like the one that's on that board. There's one on that board I like. Can I erase them?
Yeah, I don't know how I did that one. That's okay though.
Did you forget to put the 2 on end?
I forgot to, no, I had just K3 in it. So I like completely balanced the equation wrong. I don't know.
What is this?
Copper
3 carbonate.
carbonate.
Okay, this is a decomp with a carbonate. So we have a rule for it. Carbonates make
Metal plus oxide.
metal oxide plus carbon dioxide. So what's our metal?
Copper 3 oxide.
So we're gonna put an oxide, our metal goes with it, and that's copper 3. So it's copper 3 oxide plus carbon dioxide. Okay, that is just a formula that you have to learn. You have to memorize these. Okay, we have predicted it, now we build it. Copper 3, that's Cu, what does the 3 mean? That's the charge. So it goes up top, plus 3. What's carbonate?
CO3 -2.
Okay, so how many coppers and how many carbonates do I need to balance each other?
2 copper, 3 carbonate.
Okay, the question was basically saying, how do I balance the charges? Bring this 2 to the copper, 3 to the carbonate. Now I have 6 and 6,
Oh shoot.
so I can erase the charge. Copper 3 oxide. Copper goes Cu with a plus 3. What's oxide?
Oh.
It's just oxygen with a -2 charge. Okay, people are getting like confused with oxide. It's just oxygen. Just like chloride is chloride. Again, the charges don't match, so I need to bring them over. Now I have 6 and 6, so what do the charges do? Just erase them. Plus carbon dioxide. What's carbon dioxide? Alright, what's my last step? Balance it. So I have copper, carbon, and oxygen. How many coppers do I have on the reactant side? 2. Product? 2. Carbons? 3. So I understand that this 3 goes to the oxygen and to the carbon.
So you don't multiply the 3 times 3, you don't do that?
I do for the oxygen. So that would be 9. So I multiply 3 times the understood 1 of carbon to get 3. And then 3 times 3 on oxygen gives me 9. Now on my product side, I have 1 carbon and I have 3 plus 2. The total, all the oxygens in the product count. 3 plus 2 gives me 5. You see why we left oxygen for last? Because do you really want to try to figure out 5 and 9 yet? No, I'd rather put it all. Procrastination. Okay. The CU's match, the carbons do not. So what side can we change? This side. So we're gonna put a 3 in front to make that a 3. But what does that change?
Oxygen.
The oxygen. So now I have 3 oxygens here plus, how many there? 6. So I basically took this 2 and I multiplied it by 3. So I got 3 plus 6 now, which gives me not 5, gives me 9, and now everything matches. If you can do this one, you can do any decomposition, okay? Because this one we had to lasso everything, we had to balance everything, we had to remember the products of carbonates.
It's memorized like the formulas.
Well, there's only 3. Good news is there were only, well, 4 I guess, but there's only 4 total, and there's a whole unit that you have to memorize. So, but the carbonates are gonna make an oxide, and then it has carbon in it, so make carbon dioxide.
So the 8 in carbonate is oxygen?
No, the 8 in carbonate is off of that list. Carbonate is because, the 8 means higher than carbonite, I guess. The 8 is just telling you that it's on the yellow list.
When is the test for you?
I don't know yet.
I read one of the numbers wrong when I balanced it on the oxygen part. Not like a natural equation, just when I read it underneath it. Do I need to resubmit that?
Your answer is not this. Your answer is this equation with all of those numbers and letters and everything written exactly how it's written, okay? So like you will be tested on, did you put a 2 right here? Did you put a 3 and a 3? Did you put a yield sign, arrow sign? Is there a plus sign in between them? And is it balanced? Did you make the correct products? Okay? Can I erase?
That homework is for accuracy?
No. But I do recommend going and changing it so that you don't have incorrect homework and you can learn what you were doing wrong. What's next?
Cobalt chloride.
Yeah, it
Cobalt 2 chloride.
When I pull up the PowerPoint.
Okay, cobalt 2 chloride is going to produce what?
Cobalt chloride plus
Why?
oxygen.
How did you know that it was going to produce that?
Formula.
Because it's a chloride, there's a formula for this. It's going to make cobalt 2 chloride plus oxygen.
So chloride's got a chloride plus oxygen?
Yes. Okay, now we build it. Cobalt 2 is C little o with a plus 2. If you write C big O, it's wrong. C medium sized O, it's wrong. I want it to be little. Big C little o. What is chlorine?
ClO. Subscript 3.
ClO3 minus 1. Okay, how many chlorates do I need to balance that out?
2.
So we understand why it's 2.
Charge.
Because the charge on cobalt is 2, charge on chloride is 1. So I need 2 chlorates to balance out that plus 2. Then the charge is balanced, so we're good to move on. Yields cobalt 2 chloride. again, cobalt, C(O) plus 2. Chloride, what is chloride? Just chlorine with a -1 charge. Chlorite is on your yellow list. Chlorate is on your yellow list. Chloride is up here too. Okay, again, 2 and 1, so I have to bring the 2 down, bring the 1 down to balance the charges, then erase. Plus oxygen. What's oxygen? O2. Why is it 2? It's diatomic. Yeah. You sure look awake. Oh, sorry. Okay, COClO. Make sure you didn't put CIO. Okay, on especially on the computer, I know I've said this a million times. On the computer, if this is what Cl is, it looks just like Ci. Okay? And I on the computer would have to have the up and down thing. Okay? Like a capital I. Don't get confused with that. 1 and 1. How many chlorines? 2 and oxygen? 6 and 2. So the only thing that needs to change is which oxygen. This one over here. And it's only in one spot, so it's pretty easy to change. So I need to put a 3 in front so that I can get 2 times 3 gives me 6 to match up. So what's the answer? The formula, okay? This could be all kinds of wrong. I don't care what this is. I only care about your formula. Yeah.
Okay, so since, like, on the formula, since cobalt only has 1, do you have to put the 1 in the substitute?
No.
So if I, like, on the test, if I didn't put the 1,
It's perfectly fine.
And if I put the 1, would it also?
Yes.
Okay.
Okay, now what are the coefficients here? No. If there weren't a coefficient here, it would be 0. And you would have nothing. What is the understood coefficient? 1. So on the test, I can't, like if I'm asking you to do it on the computer, I'm not gonna ask you to type that out because that would be horrendous. But I may give you like A, B, C, D, different options. 1 may be no reaction. We'll talk about that in a minute. No reaction. That could be an option. But that's not an option on decomposition. Decomposition are going to decompose. So that's not right. I could say 2, 1, 3. Is that right? No. 1, 1, 3.
No.
What are those
That is
numbers?
right.
Oh, wait.
These are coefficients. So the one that is right is C because I have 1, 1, 3. Okay? It goes in order and you have to account for every single compound and element. So 1, 1, 3. So C is right. Alright, moving on. Alright, what's next?
Magnesium hydroxide.
What kind is this?
Magnesium oxide is water.
It's a hydroxide, so what does it make? Magnesium oxide plus water. Makes water because I have hydro. Okay. Now what? Magnesium has what charge? Why is it not indicated right there? Because it's not a transition metal. Hydroxide? OH minus 1. So what do I need to do? Balance those by putting a at the bottom of OH, the parentheses. Now they balance. So now I can build magnesium oxide. 10 magnesium is plus 2. What's oxide? With the minus 2. Do I need to bring those charges down?
No, they don't.
They balance out, so I'm just going to erase them.
Why isn't it the 2 already at the bottom?
Because it's not by itself. It's a compound, and the numbers down here are determined by the charges of a compound. plus water. What's water?
H2O.
Alright, what now?
Balance.
Balance. Alright, so I have one magnesium. I have two hydrogens, and I have two hydrogens. I have two oxygens, and I have one here plus one there, making 2. So what are the coefficients for this problem? 1, 1, 1. Okay, the answer is magnesium OH, in parentheses 2, yields MgO plus H2O.
Can you leave that?
Alright, last one. Did y'all have any problems with this one? Okay, I thought that you might, just because we've done 3 that had like a definite formula answer, and this one's not on that list. So what type is this? It's just a monatomic, so what do you do to it? Just break the 2 pieces apart. So it's going to be aluminum Now, right here, it's going to end up being what? This one will be O2, right? Because oxygen's by itself. And aluminum on this side is by itself, so it's Al. But there are no charges with those. There are charges with this because it's a compound. What's the charge on aluminum?
3.
Always plus 3. So now I'll bring the 3 down, bring the 2 down, and we need to balance the problem. Alrighty. How many aluminums on the reactant side?
2.
Product?
1.
Oxygen, reactant.
3.
Product?
2.
2. So we can change our aluminum, but we probably are going to have to come back and fix that because our oxygen's only on one place on this side. So I have 3 and 2. What's the best number we can make both of those equal to? 6, right? The only thing that we can really make them be is 6. And since they are in only one place on either side. Now if the oxygen was like divvied up in multiple places, then we could like go different. We could do something different. But since oxygen's only in one place on either side, we're just gonna make them both equal to 6. So how do I make this one equal to 6?
3.
Put a 3 in front. What about this one?
2.
So now there's 6. But what happened to my aluminum?
4.
2 times 2 now makes 4. So how do I make aluminum 4 on this side? Erase it and put a 4. Alrighty, that's your answer. What are your coefficients?
2, 4, 3.
2, 4, 3. Alrighty, that is decomposition. I hope that y'all are at like 80-ish% on that or higher. If you're not, I've made these videos. They're on Canvas. You can watch them again and again and again and again. But if you're gonna watch the videos, I do recommend getting out a piece of paper and actually like working it with me because I know that I can get like monotone on a video. Okay, so today we're learning about combustion and single replacement. Combustion is probably our easiest thing because you don't have to predict, you don't have to build. All you really have to do is balance. Okay, so this is that fourth one I told you had to learn. So the 3 decomposition ones, you need to learn the answer to them, the prediction. Combustion, you technically need to learn the prediction, but it's going to be the same every time. So if you recognize it's combustion by seeing a carbon, hydrogen, possibly oxygen, plus O2, this is combustion, and you will always, always put CO2 plus water. Okay? So on a combustion, the only thing that is going to change is the number beneath carbon and hydrogen, and you might have an oxygen. Might not, okay? The rest of this will stay the same. Okay? But since these numbers can differ, that means the whole equation is going to be different in balancing. Now, balancing for a combustion reaction is not the easiest thing to do. Okay, so I found 2 tricks to work it. The second one is how I've always worked it, but last year they seemed to like this one better. So with combustion reactions, I recommend putting a 2 in front of the carbon on the reactant side, then starting your tally system. Okay? Then at the end, if all the coefficients can be divided by 2, then you can divide them by 2. If not, then they stay the same. I'll make more sense of it in a second. So this is a combustion reaction. You have 3 or 4 of them on your homework. So on your homework, I don't write CO2 plus water. What are you going to put down when you see combustion? CO2 plus water. You don't have to worry about the prediction. You don't have to worry about the building process. It's already built for you. All we have to do is balance. So for combustion reactions, it is just easier to put a 2 in front and then start your count. The reason for that is oftentimes you only have one spot for oxygen. And the oxygen has a 2 on it. So that means that this has to be 2 times something. Okay? Well, a lot of times this side will end up being an odd number. And how do you make this side odd? You have to put like a fraction, right? Like some number 0.5 to make it odd. But you can't have fraction. So you would have had to multiply everything by 2 anyways. So it's just easier to do this because I've learned that y'all don't like fractions. Am I right? Yes, ma'am? Okay, so if you put the 2 there, now we're going to start our tally system. So how many carbons do we have on the reactant side? 2. Hydrogens? 2 times 4 is 8. Oxygen? 2. Product? 1, 2, 3. Your product will always be 1, 2, 3 for combustion at the beginning. Yeah. Okay, so 2 and 1. What do I need to do? Balance out my carbon by putting a 2 in front of the carbon dioxide. That messes up my oxygen, but I'm not going to worry about it yet. Okay, now what? Do the hydrogen. So what do I put in this one? A 4 to make that 8. Okay, those are both balanced. Now I can be concerned with oxygen. How many total oxygen do I have on the product side? 2 times 2, 4 plus 4. So that makes 8. So what needs to go in this blank?
2.
A 2?
4 times
2 times 2 is
8.
Oh, wait, we're 8.
But that's not 4. So I wanted to get to 8. So I'm going to put a 4 in the blank to make it 8. Okay, for combustion reactions, before you finish, I want you to write all of the numbers out to the side. All the coefficients. What do you notice about all of them? They're all even, okay? If they are all even, you can divide them all by 2.
Would you ever divide them by more than 2? If it's like 4, 16, 4, 16, could I do it by
Yeah.
more?
So if they are all divisible by 2, you can do it. What if one of them is odd? You can't, okay? So divide them by 2. Now what do we do? Change them in your problem.
You have to change them in the, balance.
Nah. Down here. You change them here. But like this is just my thought process. So like this tally system doesn't have to be accurate. 1, 2, 1, 2. Now before you finish, I want you to ignore your tallies and think about the problem without them. Recount. This should be a good habit on like any problem you do, regardless of combustion or not. Count it up. How many carbons do I have? 1 and 1. Hydrogen? 4 and 4. Oxygen? 4 and 2 plus 2, 4. Okay, good. Next, we're gonna put the 2 in front just because. You don't have to, but like, I think that is easier, like just reducing than having to divide something by, or having to multiply and deal with fractions. Okay, try to work that one by yourself.
You get that out.
Okay, is this what y'all got before you did your thing? I put a 2 there, so then I got 6, 16, and 2. So I said 6 on this side, put a 6 on this side. 16 on this side, so put an 8 to make it 16. Then I add up my oxygen. 6 times 2 is 12 plus 8, 20.
I just didn't get, I got all of them, I just didn't figure out how to do the 10. I got 6, 8, and 14.
6, 8, and 14, right here,
No, like,
here.
balancing it out, I got 6, 8, and 14.
You must have not added your oxygen right. Right, I'm thinking that you ought to do
But
this.
6 plus 8 is 14.
6 times 2 plus 8.
I put a 3 in front of that now.
In front of the second C.
It all balances
I
out.
got everything but.
Because you did, you.
Because
Alright, hold on, let me back up and I'll show you again. So I put a 2 in this blank just to make it easier. CHO, hold on, I'm showing you. So, how many carbons? 6. Hydrogen. 2 times 8. 16. Oxygen.
And that's where I.
2. Okay, this side. I have 1, 2, 3, same as always. Alright? So now I need to start making them balanced. I have 6 carbons, so I need to get a 6 in front of the carbon dioxide. I have 16 and 2, so I need to put an 8 in front of the water. Now I need to count up my oxygen. 6 times 2 plus 8 times 1. That's what we're looking at. 6 times 2 plus 8 times 1.
I'm confused why you put a 6 in front of the CO2 when you put.
Because I put a 2 here.
Why couldn't you just put a 3?
You can't,
3 times 2 is 6.
The 2's on the.
the 2's on the oxygen, not on the carbon.
It's on a parenthesis.
Right.
So
Come here, I'm so confused.
So what if I,
You
you
only
only
have
have,
2, 6.
but
Oh,
that's on
that's
the
not
option.
This one actually makes sense to me.
So this makes 20. So what do we need to say? 2 times what to get 20? 10. Now what do? We look at all of them. 2, 10, 6, 8. Are they all even?
Yes.
Yes. So you can divide them all by 2. Which would give you 1, 5, 3, 4.
I put a 4 in front of that other 2.
Well, you did something. Okay, then you count. If you got a 4 for the H2, count. It's probably not, it's not gonna add up right.
Didn't you say these are the ones where you have to like start completely over if you get it wrong?
Yes. 3 and 3. 8 and 8. 10 and 3 times 2 is 6 plus 4 is 10. Yes, on these, if you get it wrong, there's no way you're probably going to back up and like change a few numbers and get it right. You're about to just erase the whole thing.
How do
Sure.
you know if you get it wrong? Like, see, she balanced.
Mine balance
Oh,
out and I didn't
because,
get what you wrote.
no, I didn't.
Then they don't,
I
do
didn't
not balance out.
multiply.
No,
What
I'm
did you
saying,
write?
like, you know you didn't.
What do you have?
Still balance them out right.
2, 3, C,
Oh, yeah, I
H8
messed up
plus
now,
4O2
Yeah,
yields
you are content,
6
so you
CO2
did that wrong.
plus 8 H2O.
Okay, let's count. Ready? How many oxygen? 6 and 6. Okay.
Oxygen?
Carbon, sorry. 6 and 6. Okay, hydrogen. 16, 16. Now I have 8 here. I already have 8 here, plus the 2 that's there. You forgot the other one.
Please do that.
Yeah. You have combustion reactions on your homework. That's going to be where it challenges you to balance it. You're going to need to put the 2 in front, and then if you don't get it right, just start over. Now, I will tell you number 2 on your homework is interesting. You're going to put the 2 in front. You're still going to have the problem of the fraction. Okay? So then change it from 2 to 4. Just go up by 2.
You said your other class didn't like this way, they did.
I don't know.
What is on this blues?
Synthesis, decompent, combustion.
See, it's more. Okay, see, someone else told me it's someone too. And then, do I have to memorize, like,
For the decomp?
yeah,
Yes,
the
those 3.
carbonate and like the.
Who's it?
Alrighty, so next is single replacement. So single replacement, I don't know if you're gonna find them are hard or not. Like, I don't necessarily think they are. All my other classes seem to be okay with them. It's just kind of like we have to ask new questions this time. So pay attention or you're gonna get lost in this one. Single replacement is a single replacement. So we are trying to replace a single element with a competing element. So look under your desk and get the orange sheet. Yeah, I like my colors. The orange sheet has 2 sides to it. One is for single, one is for double. The single one is the up and down one.
I don't think it does anything.
The activity series. Okay, the activity series is comparing reactivity of elements. Do you see how there's 2 columns? Okay, one column is for metals, one column is for non-metals. Okay, metals compete with metals. Non-metals compete with non-metals. They do not compete with each other. Okay, so the first thing you have to do when looking at a single replacement is to figure out which column we're looking at. So a single replacement will always look like element plus compound, some type of ionic compound. Okay, so this is a new thing that we're looking at. The other ones were element plus element, or compound yield, or the combustion, which was very, very specific with carbon, hydrogen, or oxygen plus O2. Okay, so this is a new type. So the first thing you do is you look at the element that is by itself, and you determine if it is a metal or a non-metal. So what side of the list is it on? Okay? Once you find it on the list, you look in the compound for the other element that is on the list. Okay? So if this element is a metal, find the metal in the compound, which will be the first thing, and you're going to be comparing those on the list. Okay? The element and the element in the compound.
What do you mean by computer?
Which element?
Hold on.
Wait, which element of the compound?
Whatever is similar to the one that's being added. So find on your list K and Al. Potassium and aluminum. The one that is on top, it wins the battle. So which one wins? Potassium, K. Okay, so what that means is that potassium is more reactive than aluminum. So if K was being added, so like say K is A, does that make sense? If potassium is the element that's being added, and say the compound is like aluminum with some type of non-metal, okay, you would be looking at K and saying, okay, K is a metal. So I need to find the metal in the compound, okay? So I'm comparing K with Al. Which one is higher on the list? Potassium. So if potassium is higher on the list, that means that potassium is going to beat aluminum out. So the reaction will happen, and K will take aluminum's place and switch it out. So we will replace.
Are they both?
I thought you said it had to be a metal and a metal, like fighting.
Aluminum's a metal.
Are they both gonna be,
It's a metal. Think about aluminum. Yes, because they're both metals.
Maybe some is the metal, and then the other side is the non.
Not all. They're metal. The metalloid.
Oh, so aluminum is not gonna be on the
compared to anything.
So the question for single replacement, so single replacement, you are going to be asking yourself, will these reactions happen? Okay? We're still gonna get to the point, it's a reaction, we're still gonna get to the point where we predict, build, and balance. But the first question is, will it even happen? If the element being added is stronger than the similar element in the compound, it will happen. So let me show you an example. Oh, by the way, I recommend going ahead and taking a picture of this because you're going to need it for your homework. And it's just easier if you have a picture on your phone so you don't have to go find it on Canvas. And then go ahead and write this down. Lithium plus zinc 2 acetate.
Do we need to write down the slot, like the questions we need to ask?
I would.
What questions, right?
Because these are all the questions you're going to ask yourself so that you can ask this big question. Will the reaction happen?
So if two elements don't switch places, the reaction doesn't happen.
If the reaction does not happen, you will write no reaction. I'll show you one of those as well.
So like on our test, we're gonna have to make those questions.
Just do it
Yeah.
again.
Well, we have
This
this.
is helping. Yes.
This doesn't make any sense. Like how that's described.
I was supposed to be answering.
We're about to do it as a class.
If the lone element is higher than the
You want me to explain this to you? So you have to ask yourself, what is the element being added? Okay, on this one that we're dealing with, it's lithium. Is lithium a metal or non-metal? It's a metal. So this one was saying, okay, metal or non-metal, well, it's a metal. So you're gonna compare that metal to the metal in the compound, okay? If the metal being added is more aggressive than the metal in the compound, then the reaction will happen. If it is not, then the reaction won't happen. So here we go. Lithium plus zinc 2 acetate. I know what element is competing. I know it's lithium, okay? So the first question is pretty easy. I know that one of the elements in competition is lithium. Lithium is a metal. So go into your compound and find the other metal. Zinc. So it's lithium versus zinc. That's who is competing. So the question is, which one's gonna win? Lithium, because lithium is higher on the list than zinc. So lithium is our winner. Does lithium have the compound? Is it in the compound? No, so put it in the compound. Whoever wins the compound, lithium is our winner. Yay! Lithium is stronger, so it is going to come in there, take zinc's spot, and kick zinc out. So they are going to switch places.
Is zinc still gonna have the 2 charge?
We'll see. Depends on if it's alone or not. So we're gonna switch those 2 places. So zinc is now going to be left alone. If it's alone, can it have a charge? No. Okay. Plus, what compound do I get?
Lithium acetate.
So the big question is, will the reaction happen? You can determine that by saying, is lithium or is zinc the winner? Lithium's a winner. So lithium is going to beat zinc out of that compound. Okay? So the reaction will happen.
So the reaction only happens if the
This one is better than this one. Okay?
What do you do with the charge that zinc comes with?
It goes away. We'll talk about that with redox reactions later. Okay, we have now predicted the product. Now we're back to our predict, build, balance sequence. So we predicted, now we build it. Lithium is Li. What is zinc 2? Yes. What is acetate? Do you know a non-metal of acetate? You know a polyatomic.
C2H3O2 negative 1.
You need to look on your yellow list. Acetate is C2H3O2 minus 1. So, all of acetate has minus 1, and, zinc has a plus 2. So what do?
Switch them.
Lasso down, bring the 2 to the outside, bring the 1 to the outside, and then the charges, I can erase them. Yields, huh?
What, how do you write this?
So
Cause I
on
don't-
that side you write the one that was like competing, and on that side you write like
The one that lost. Zinc is now Zn with no charge because it's by itself. Plus, now we need to build this compound. Well, acetate is the same thing as it was.
but now lithium has a charge on it.
And now lithium has a charge that's in a compound. What is the charge on lithium?
Plus 1.
Yes,
Does acetate have a negative 2 charge?
negative 1.
So does zinc not carry the 2?
No. It loses its charge. Oxidation and reduction reactions are a 6th type of reaction. It's called redox. It's not actually doing anything new. It's just going back into this and saying, okay, where did the charge on zinc go? It's explaining that, so we'll get to that point. Okay, and since lithium is plus 1 and acetate is minus 1, those don't do anything, so I just erase them. Okay, the easiest part of single replacement is the balancing part. So we're gonna balance. I know Li and zinc. But what I did not know last year, I learned about halfway through, is that do you see how acetate stayed together? Why would we break that into its pieces when it stayed connected? Okay, so since we have acetate coming in, acetate coming out, we can just write down here acetate, C2H3O2. And we can count it as a whole thing instead of as like its components, okay? We could not do that for decomposition because decomposition, the whole point was to take it and break it. Well, it did not break here, it stayed together.
Well, what if we had like another
Normal.
oxygen?
Well, we would use oxygen separately.
So
And we would still keep acetate together and just do oxygen separately, wherever else it was.
So you wouldn't do.
If acetate goes in and then comes out, there's no point in breaking it all apart.
But if there was like plus O2 on one side.
Well, it wouldn't be, but if there was, then we could do that down here separately. Okay, so how many lithium is on going in? 1 coming out. 1. Zinc. 1 and 1. Acetate. No.
2 and 1.
2 and 1.
So you put
So you put a 2 in front of lithium and
No. Oh wait, yeah. Sorry, this side. Yeah, you put a 2 in front of this. Why can't I put a 2 here?
because it's a compound.
Because it's a compound and you cannot change those subscripts.
and then you have to put a 2 in front of the
Then you would put a 2 in front of Li to change it. See, these aren't that hard to actually balance. They're not even that hard to predict. The only question is you have to figure out, will it happen? Like what's competing, what wins, and does that mean the reaction happens or not? If the reaction happens, then the switch thing is not that hard. Then the balancing is normally not that hard. So your answer is 2Li plus Zn, open parentheses, C2H3O2, 2. Yields Zn plus 2Li C2H3O2.
It's how I get all these Excel for like names of
Naming is hard. And the worst part is y'all came in like virtual, so we really we did a lot of naming, we took a test on it, we spent a lot of time on that. So naming is like the hardest part, I think, because of all the rules. I think I did put some videos up. Yes. Yeah. I would stop, but I can't stop the video. I would stop and let y'all go, but I can't stop the video. Okay, so here's another one. So ignore this part because that's just telling you that if we do move forward, the copper needs a +2. Okay, so, but we have to figure out, are we even moving forward yet? So what two elements are competing? Copper, which is Cu, versus aluminum. Why did you know that it was copper and aluminum? Metal. And it's a polyatomic, it's not normal list. Which one wins? So aluminum is crowned our victor. So is copper stronger? No. Can copper come and take that place? No. So the actual answer is no reaction. And you stop there. So my options could be, I could finish it out and create the compound for you, balance it and everything. But your answer is still no reaction. Just because I finish it on a test does not mean it actually happened. I can write it all day long. Don't y'all like these though? That's all we do.
They're easier to remember.
Huh?
They're easier to remember. So we
One
have
position, there's 3 formulas to remember. So you say,
is at the top, AL's right here, and copper's right
I
here.
like
So
these.
the one that's in the compound beats it, and the copper can't take it.
So last year I kind of taught it like sulfate was my prize, and who wins my prize. Okay, so copper is competing with aluminum, and aluminum is here, and copper is where? Here. So aluminum wins, but aluminum already has the prize. So does it need to go get it or anything? No, no reaction doesn't happen.
Okay.
Okay, let's do this one. Now this one you have to be careful with, because this is compound plus element. It's still a single replacement. I just took the two things and put them backwards. So I know that fluorine is competing. What can fluorine actually compete with? No. Iodine. Look on your list. Is magnesium on the same column as fluorine? Fluorine's right here. It can only compete with this little bitty column. Right? It can't compete with the other column. It's not on the same category. So F is competing with I. And which one wins? F does. F wins. So fluorine comes and kicks iodine out and switches places with it. So does the reaction happen? Yes. So the reaction will happen. Yes. So I'm going to make it happen. Here we go.
what was behind the arrow? When you were
Fluorine won. So fluorine is going to come take iodine's place and flip it out.
Would you go ahead and write it?
Wait, can you leave that for like just a
Fluoride
second?
plus
so I can
iodine?
correct
Yes.
my mess?
You would go ahead and write it on the little side piece?
I'm about to write it down.
Okay.
So it's going to flip out. So these two are going to switch. So on your product side, you're going to have magnesium, but now it's with iodine. No, fluoride. Sorry. I was like, wait, what's wrong?
Wait, do you take
How do you know to flip it in?
Wait, what?
Fluoride, because it's just flipping places, and in the compound, it's I. So fluorine's going to switch to fluoride. Because it's a compound. Fluoride is in a compound. We can't end a compound with fluorine.
So
When it's by itself, it's going to be iodine. Fluoride has a charge, fluorine does not. Iodide has a charge, iodine does not.
Where does the charge go?
Redox reactions. We'll talk about that later. Can I raise my little arrow?
Yeah.
Okay. Okay, we predicted it, now we build it. Magnesium is Mg with a +2. Iodide is I with a -1. The 2 has to come to the bottom of I and the 1 to the bottom of Mg to balance that charge. Then I can erase. What is fluorine?
Plus minus one.
No. Fluorine.
Minus one.
No.
It
Fluorine
doesn't have a charge.
doesn't have a charge. Fluoride has a charge
Why does it have a charge?
because it's by itself. So fluorine is F2 because it's by itself, it's diatomic. Magnesium fluoride. Mg with the +2, what's fluoride?
Minus one.
Yes, F with a -1.
Because it's I.
Yes. Ide means charge. Bring the 2 down, bring the 1 down, erase the charges. What's iodine?
Nothing.
Minus one.
Nothing.
No.
It's by itself.
I2.
Oh, so it's canceled.
Alright, so now let's do what?
Balance.
Balance it. It's already balanced, but we'll make sure. 1, 1, 2, 2, 2, 2.
I didn't get to. Oh, this one.
It's a.
It's
Alright, I have 2 more things to teach you, but they're still a part of single replacement.
So what?
Still a part of single replacement. Can I erase yet?
Oh, isn't it the reactivity in water?
Yeah.
Acids?
Can I erase?
That's not.
When's our test on this?
Not yet.
She doesn't.
You do know.
Not letting
We have a
us
quiz
know.
next class, right?
Yeah.
Yes.
Okay, so
Hold on. Thanks for telling me.
sodium plus water. So if you notice on your orange sheet, hydrogen is in here. Okay? All you really need to know is that hydrogen in water or acid, because that's the only 2 places that really shows up as a charge, can be replaced by any of these elements. Okay?
What do you mean can be replaced?
The same thing that we've been doing.
Oh.
So this one is particularly not fun to balance. Sodium plus water. But when you're writing it like this, sodium is Na. Since we're competing sodium and hydrogen, but the hydrogen's in water, I'm gonna write hydrogen differently. Water differently. Instead of writing H2O, I'm gonna put that hydrogen out front so that I can replace it. Okay? So it's gonna come in and take hydrogen's place.
Does that mean it's in a 2?
Because hydrogen is lower than sodium. Sodium wins. So sodium is gonna take hydrogen's place. And you're gonna get a sodium hydroxide because what's left is OH. So sodium is +1, hydroxide is OH -1. Well, they balance. So it's just NaOH. And then plus hydrogen. Hydrogen got kicked out. But the fun thing is hydrogen is diatomic. So plus H2.
So why didn't you, when you replaced it, why didn't you replace both of them?
Just because that's what happens. If you write water like this, you won't forget that that's what happens. Okay, now this is fun to balance because I have hydrogen in 2 places.
But OH can
I'm still confused why you're writing it like HOH.
Because-
She can replace it.
Because when a metal reacts with water, you get a hydroxide. So it's easier to write it HOH so that you can see hydrogen hydroxide and how you can compete hydrogen with Na. So that Na takes that spot and kicks the H out.
So it's not like the other one where like OH was like there and then OH came out.
OH is just like your non-metal side.
But that
One
doesn't make
second.
sense. Okay.
We didn't kick any out though.
I could kick the hydrogen out,
But there's an H gas on the other side.
which is the
There's
kicked,
another
that's
one.
what got kicked out.
Did you say the metal?
That's what got kicked out.
I still don't understand why we're writing HOH. It just. Why are we writing the HOH? Like, I
Because-
said that, but I'm still confused.
Because I told, you have to get a metal hydroxide out of these, and so it wouldn't be clear that you got an it wouldn't be clear that you got OH out if you wrote it like this. Because then you would think that you would only have an O.
Cause then you would replace,
But this is just what happens when you react it with water, you get an hydroxide out. So it's easier if you write it HOH so that you can see this being replaced. So Na comes in and takes H's place and kicks the hydrogen out. But hydrogen's diatomic, so it has to have the two.
So then they don't balance.
They don't balance, we gotta balance. Yeah, sorry.
Well, it end up being, since you wrote all those arrows, changing the H, so would it be H plus an AOH on the, side of the arrow? Let me just.
Hold on, you're gonna be in this.
Since you like traded those
It
out,
makes
why
no
did you
sense. It's like, I don't get you.
traded them out on the other side of the arrow?
She's
but-
there.
How do you remember? Because on this side it doesn't get traded.
I'm lost on this homework. Which part?
That's what you're putting in.
Okay.
Na.
I have some
Okay, then that's-
transition metals and I don't know the charges, so I'm gonna.
Change.
Yeah, I just.
Is she videoing in here?
Yes.
This is the video block? Yeah. Okay, what is the charge of zinc and the charge of nickel? Give this one a plus 2, give that one a plus 1.
Alrighty, so we're running out of time. This one is not fun to balance. I want you to try to balance it, but we're just gonna stop the video. The other thing that you can do is if this is an acid, you can do the same thing where the H and the metal competes and switches out. Okay? We can cover that next class.